Hello, today we're looking at sequence reconstruction using LLMs and RAG project. So basically the problem is that people who reconstruct chemical synthesis and chemical steps need to look at various different sources to make a chemical synthesis to reconstruct it. But today we're going to use RAGs and LLMs to solve this problem. Let's move on to the pipeline. So first of all, user inputs the data in query, and then it is stored into a database as vectors. Then the LLM retrieves the most relevant documents in the retrieve bit, and then after this, there's a router that checks if the data is sufficient to answer the query. If it is not, then a web search is used to get more information, and in the end, the output is generated. Now let's move on to the code. This bit of the code shows the ingest bit, and this divides the queries into chunks of tokens, and the tokens they're turned into Nvidia embeddings, and after that they're stored into the database. So now let's run it, and now we can see that a database has been made in the left. Now let's move on to the main pipeline where we're using LangGraph, and we can use different tools. We can see the route instructions which decides if a web search is required. So we can also see that we have a retriever node, the different nodes. So this is the retriever node which retrieves data from the RAG pipeline. We have a generation node which inputs all the questions asked by user and uses LLM to generate the sequence. Thirdly, we have the web search node. It inputs the question and documents and appends all the documents that it gets from the web using Tavily, and all these different nodes, they update themselves after they run. And now we can see our conditional edge, which is basically a router, and it tells us which node we should go to next. Now after running this file, we can see that the RAG is being used, and we get a reaction and an explanation that in the output, and this output matches our expected output. So that's it. Thank you.